Hi, I'm Lynn Langett. Welcome to my multi-part series on understanding Hadoop MapReduce fundamentals. This is part 1 of 5 parts. I hope you enjoy it. In this course, we're going to cover many aspects of working with the Hadoop storage and MapReduce processing systems. We're going to cover the following concepts. What is Hadoop itself and MapReduce? Why developers might choose to use the MapReduce API for particular data processing problems. We'll drill into the specifics of actually using the MapReduce API, including demonstrations around setting up a development environment, running and writing MapReduce jobs that include the quintessential word count, which we'll do with different languages, tools, and editors both on-premise and on the cloud. We'll also look at other types of MapReduce jobs, other languages, other tools, and other editors. After we've gained a core understanding of basic MapReduce jobs, then we'll look at optimization of MapReduce. Now this is a huge topic, and I've attended and could probably give a week-long course, a little bit too long for the format of this particular course. But we'll get some useful tips based on real-world experience and lots of study and reading. So I'll talk about job optimization and optimization of the map phase and the reduce phase in particular. To close out this course, I'll make a comparison of the current state of Hadoop and MapReduce to the evolution of the APIs themselves, along with other emerging big data technologies that build on, supplement, or possibly even replace MapReduce. So leave the course with a solid understanding of what problems to solve, how to work with MapReduce, and when to use it and when not to use it. So to get started, we need to have an elevator pitch or basic understanding of what is Hadoop itself. And really there are two parts to working with the Hadoop ecosystem. The first is the storage. So Hadoop is built on work that was originally done at Google to solve the business problem of indexing the entire internet. So the first part of it is a massively distributable file system, which is called HDFS. Now this is built on GFS, or the Google file system. Storing lots and lots of data is of course only a part of solving the big data problems that we deal with. The second part is getting meaning or value from that data. And you can see in the picture shown below that we have the data coming in, and then we have a compute cluster that performs job processing to get meaning out of that data. Now that's called MapReduce. And the idea around this is that you have parallelizable processing against massive amounts of data, automatically and parallelizable. They actually call it embarrassingly parallelizable problems. So that comes again out of work that Google did to solve the problem of indexing the web. There are many different ways to work with Hadoop. The core implementation is open source, and it's available for download from the Apache Hadoop site. Now there are several augmentations and enhancements to those core Hadoop binaries that are made available through vendors, most of which have a freemium layer of access along with an enterprise layer for which they charge. The premier vendor right now is Cloudera, and their distribution of Hadoop is called CDH4 and has something called Impala we'll talk about later. There are other major players in this market, Hortonworks, MapR, and then some cloud vendors such as Amazon and Microsoft with Windows Azure HD Insight. During this course, we'll look at a great majority of the core distributions. As we're starting to think about Hadoop and understanding that it consists of the two parts, the massively scalable data storage and included parallelizable processing and computation, we need to think about in what business situations we'd use Hadoop. Now in the world of big data, we actually often hear these 3 V's: volume, velocity, and variety. And this does apply directly to Hadoop. If you're in a situation where you're capturing huge, massive amounts of data, and when I say that, I mean not gigabytes, not even terabytes often, but data that's scaling to the multi-terabytes or even petabytes, then Hadoop is often looked at because the storage can be run on commodity hardware that can really infinitely scale. Also, in getting meaning out of that data, the MapReduce API, as I mentioned, is by default parallelizable. once you've written your processing algorithms, this is comparable to what we think of as ETL, or extract, transform, and load. You can then scale more and more data against those algorithms that you've written to both map and reduce. And also, Hadoop can be better suited for particular types of big data problems, and we'll go into some specifics in just a minute or two here. So I pulled from Cloudera's website, so you can see the ones that you're probably most familiar with is ad targeting from some of the big social networks such as Facebook. Facebook is in fact one of the largest users of Hadoop in the world. But some other types of problems that you may not have considered, such as point-of-sale transactional analysis. You may have thought that that might be a problem better suited to a relational system. Again, coming back to the 3 V's, volume, velocity, and variety. So Hadoop is suited to classes of business problems where batch processing is acceptable. Very important to understand that the MapReduce jobs are run in batch rather than interactive or immediately, where very huge amounts of data will be continually coming into the system, and where this parallelized processing is going to be a more efficient way to address some of these business needs, like risk modeling, customer churn or turnover analysis, recommending, you might like, threat analysis, I mentioned ad targeting and point of sale, trade surveillance, search quality, and a data sandbox to just explore data. That's probably the use you didn't think about. Another point to consider is Hadoop really becomes part of many customer pipelines. It is, as I mentioned, a step of ETL in oftentimes a multi-step process that might actually ultimately present this data through another viewer or lens, or possibly even an intermediate aggregation engine such as SQL Server tabular models. So it's really important to understand that Hadoop goes on the front. Basically, when you're receiving the hugest volumes of data, goes first to handle that processing of those massive volumes, and then other steps may occur in the data pipeline. Many companies are using Hadoop and have been using it for years. The most commonly known are Facebook, and a lot of the Hadoop access technologies were actually developed by Facebook and the other very, very well-known user of Hadoop, which is Yahoo. In fact, one of the major commercial distributions of Hadoop, called Hortonworks, is a group of former Yahoo employees who are building tools and services on top of the Apache distribution. In fact, when I spoke to the CEO of Hortonworks last fall, he talked about the fact that they have the ability to still test any new Hadoop features on the Yahoo data sets as a competitive advantage for their particular company. Other companies using Hadoop are Amazon, eBay, American Airlines, the New York Times, Federal Reserve Board, IBM, and Orbitz. You'll notice that these companies are all American companies, and this is because I live and do consulting mostly in the United States. There are many companies in Europe and in other parts of the world that are also using Hadoop. I'm just personally most familiar with these United States-based companies. Another important consideration when we're taking the time to learn about the new technologies that Hadoop encompasses is our employability. Big data and the methods of working with larger and larger sets of data is a very hot topic in the data world, and this Hadoop job trend graph comes from an online employment agency called Indeed, and you can see that it's spiking exponentially in terms of the employability of people with Hadoop skills. Now, Hadoop skills in particular are Hadoop administration skills, which really won't be covered in any depth in this course, so you get an introduction. But also, and probably the most employable skill for Hadoop, is the ability to use, appropriately write, and work with MapReduce jobs. So such is the focus of this course. So drilling in with a little bit more depth, as I mentioned, Hadoop is a set of Apache frameworks, but it also includes more. Now, as a point of pure information, you could run Hadoop, and some people do, with just the binaries, which would consist of the data storage, or the HDFS, which is also called the Hadoop core, running on commodity hardware, usually running on the Linux operating system. Of course, this is horizontally scalable, as I've been mentioning. Now, this will also run on some other operating systems depending on the distribution. Microsoft has actually worked with Hortonworks and done a port over to Windows It's still in private beta, although the most common operating system for HDFS is Linux at this time. Now, on top of the Hadoop core layer, the binaries include the MapReduce API, which allows job-based parallelizable processing across data in the HDFS structures. Also, MapReduce has fault tolerance built into its algorithm execution. By default, HDFS cluster stores each piece of data 3 times, and the MapReduce algorithm expects that there will be hardware failures in this commodity hardware, so it has automatic retry built in. There are many, many, many knobs and widgets you can tune, so to speak, in the MapReduce algorithm in the server configuration. Again, those are more on the administrative side, although I'll mention some of the potential here. We're going to focus on the actual writing of the MapReduce code in this course. Now, sitting on top of most commercial distributions of Hadoop are other tools and frameworks which can improve the usability and usefulness in your particular business situation. Those are in the form of libraries and tools. So the data access layer, the most common ones that we see are HBase, Hive, Pig, and Mahout, or Mahout, it's pronounced. It depends on where you come from, I guess. We will take a look at some of those in a very light fashion, but again, the core of this class is MapReduce. On top of that, some of the vendors provide additional higher level tools and libraries. Hue from Cloudera, for example, is a tool that we'll be using. It's a graphical user interface, which makes working with Hadoop a little bit simpler when you're first starting. Now, most commonly, when you see the Apache distribution, you see people working directly from the Hadoop command line, and you will see that in this course as well. However, I tend to use GUIs to introduce topics when they're available because it's just a little quicker. Scoop is a library of particular interest to this audience because it allows interoperability between relational databases, in particular SQL Server and HDFS. And then sitting on top of most of the implementations of Hadoop are some monitoring and alerting tools. These are usually ones that you purchase from various vendors. Can be a Hadoop vendor such as Cloudera, MapR, Hortonworks, or an integration vendor such as Greenplum. There are some other multi-cloud vendors that are talking about data solutions across different vendor clouds such as RightScale that have tools as well. So drilling in even deeper on the core parts of the Hadoop distribution, you have HDFS storage, which by default but can be tuned, has 3 copies of each particular piece of data. And the concept is that Hadoop or HDFS will operate on larger size blocks of data than the traditional operating system file system, which is like 8K. So the blocks will be 64 or 128 megs each. This is set in the configuration file. And HDFS is designed to be run on commodity hardware and can scale to thousands of nodes. In fact, one of the first levels of optimization is simply to add more nodes. And it's something that shouldn't be overlooked in light of tuning MapReduce. Sometimes that's just a simpler way to do it because it's cheaper to go buy more nodes rather than to spend a lot of time fiddling around tuning a MapReduce, which can be very arduous and take quite a lot of developer time. Sitting on top of the storage is the MapReduce API. We're going to be dealing with the version 2 for this class. There are 2 different versions which are very similar conceptually. In terms of the understanding core MapReduce, there's not much that is different. However, the API itself is slightly different. So if you are in a situation where you're working with MapReduce 1, there'll be slight language differences that you'll see. So MapReduce is designed to allow you to write batch processing jobs for your data stored in HDFS, and the concept is that the first step of the job, the map, will be localized to the various nodes in the cluster. So the compute will come to the data rather than the data traveling across the network to be operated on. Now once the map phases are completed, or the maps, then the results will be then parallelized through what's called a shuffle and sort, and then the reduced jobs will run. So the whole thing together is called a MapReduce job. As mentioned, because you get 3 copies of each block of data, internal to the MapReduce algorithm is this idea of fault tolerance with auto retries, which of course any of these settings can be changed in the cluster configuration file or even at the level of an individual job, but these are the default settings. And then most generally, a core distribution of Hadoop will include other libraries, as mentioned, to make the data access simpler and more SQL-like, ANSI SQL-like, rather than at the MapReduce level. This course will focus on the MapReduce level, though. So let's just take a little bit deeper look into the physical storage of HDFS. Because it's important for us to have some understanding of how our MapReduce jobs will run when we deploy them to an actual cluster. So each of these squares represents a physical machine, and on each machine there would be a Java virtual machine. So in this case we would have 5 Java virtual machines, and they would run daemons or services to perform management. Now we have the HDFS management, the storage management, and we'll also, coming up here, talk about MapReduce, which is the job management. So there will be one machine that runs the name node service, which maps the information out to where the various data nodes are. And by default here I've just shown 3 data nodes, which is a simplest possible sort of a staging cluster environment, because you normally, as I mentioned, have 3 copies of the data available. Now when you are developing, it's common that you will have the name node, the data node on the same machine, and you'll work in what's called pseudo-distributed, where you'll have just one data node. In fact, you do not actually have to use HDFS to test out your MapReduce. You can run that against the local file system, and some developers do that as well. The secondary name node, it depends on which version of Hadoop you're working with. A relatively new improvement to Hadoop is this ability to have a high availability against the name node. And this was released late last year into most of the commercial distributions. Up until this point, the name node, if it were to fail, would cause the Hadoop cluster to fail. So there wasn't high availability built in. And some of the commercial distributions are still based on the older binaries of Hadoop. So that's an important thing to check to see if the HA is available. High availability is something that you should discuss with your Hadoop administrator. But for a development environment, normally you're just going to have your daemons running all on the same machine. Speaking of developers, this is an image from Amazon representing their implementation of MapReduce, which is pretty standard at this level. And they've used colors here to indicate for us developers so that we can have an understanding of how MapReduce actually will be executed through our code on the Hadoop cluster. So you can see we've got 3 major parts, and to introduce the topic, as a developer we will write the code that will implement the map and the reduce by default, and this is required. So there's no sample or stub or anything. We have to write this out. So the map code takes our input values on each of our nodes, and each of the squares here in the diagram are representing a physical data node, and performs some type of process on the data on each node, and then comes with some output for each node. Once the mappers are complete, then the shuffle and sort, which they call the secret sauce of MapReduce, takes over and then does a movement of that data to the appropriate reducer nodes. Now this happens to show 3 mappers and 3 reducers, which is not representative of actual MapReduce. Generally it's exponentially more map jobs and quite substantially fewer reduced jobs. So it could be 1,000 map jobs and 200 reduced jobs, or so on and so forth. Also, it's important to understand that a MapReduce job process flow is designed to do one type of process against a large set of data. It's quite common in the real world that multiple MapReduce jobs are chained together one after another, kind of like, from us coming from the relational world, multiple tasks in an SSIS process. As mentioned, the Hadoop ecosystem is HDFS, which is the storage plus MapReduce, plus several other tools and libraries, and this is just a different picture of it. A couple things I wanted to call out here. because again, we're focusing on a very small part of the ecosystem in this class, is there is a workflow engine called Oozie that allows chaining of MapReduce jobs, but as I mentioned, the Hadoop ecosystem is relatively new compared to some of the data ecosystems such as SQL Server that many of people listening will work with. Oozie, for example, is often written as pure XML. There are some very basic GUI tools, but nothing like an SSIS that I've seen as of the recording of this video. So the tooling is a moving target, if you will, in the Hadoop ecosystem. Another thing I want to call out in this diagram is on the bottom left, you'll see Scoop, which is a utility to do import and export between RDBMS, including SQL Server and HDFS. So lots to cover, and as you learn MapReduce, really you need to understand that MapReduce to the Hadoop ecosystem is what C or C++ is to the language system. So in other words, if you are the kind of person or have the kind of situation where you want to work in a very low level, direct type of way and you need lots and lots of control, or you're just comfortable there, then you're going to be comfortable in the MapReduce world. If, however, you don't have the complex business need or the professional experience, you may want to address Hadoop data at a higher level. And I will introduce some of these things in this course, but that's not the focus of the course. Things like Hive and some of the visualizers that you see on the bottom right there that just allow you to actually visually interact with the Hadoop ecosystem. So there's lots of different options, and it's very much an ecosystem in development and movement. To that end, this is a data visualization that gives a sense of the amount of activity, tools, and customers that different companies are working with around the ecosystem. And you can see the major players here are Cloudera, who has dominance in the market. Hortonworks is quite significant, IBM as well. MapR is, again, coming on strong. Microsoft has a presence with their port, but all their products are in beta. And the cloud leader at this time is Amazon. But there are others. EMC has done quite a lot of work. Datamir, who actually made this visualization, has done work as well. So it's a lot of new innovation, and it's a very fast developing ecosystem. So in this world of complexity and ecosystem development, who do I recommend that you follow? Because you can't possibly follow everyone in that last graphic. These are the people that I pay attention to in terms of developments around Hadoop, and I recommend that you do the same. So of course, the core work is done and posted in the open source repositories that for Apache, and those projects, and there are many, are frequently updated, and then vendors create commercial distributions around portions of what's in the open source repositories. Cloudera, as I've been mentioning, has the greatest amount of market adoption. Hortonworks, based in Seattle, has been working very directly with Microsoft as well as getting customers on their own. MapR has been working on their own, and they've done quite a lot of work with actually Amazon. Way out in front on cloud implementations of MapReduce is Amazon. They've had commercial distribution for several years now. And Microsoft has a new offering, which is at the time of this recording still in beta, called HD Insight, or Hadoop on Azure. So these are the folks that I follow. There are more out there, but this covers the majority of the landscape at this time. Speaking of Hortonworks, I took a page from their Intro to MapReduce video, and I liked the representation of the various daemons or services overlaid to the physical nodes. Now their diagram is pretty accurate, but they are missing one additional server. So you can see up at the top they have green is for the MapReduce daemons and blue is for HDFS daemons, which I'll remind you are each a separate Java virtual machine. At the very top, they should have another gray square underneath the job tracker and the name node, which would run on a server. And if you had high availability, there would be a secondary name node. Then they have 3 additional servers with HDFS with data nodes, and they're showing the 3-part redundancy there for each piece of data. And then they're showing task trackers. So the job tracker is the method by which the MapReduce jobs are created and run, and the task trackers run the individual portions of each job on each data node. So given that we have this background, it's time for us to get started setting up a Hadoop development environment. To do that, there are 4 considerations. You need to figure out where you're going to get the Hadoop binaries from, where you're going to put them, where you're going to get data to process and work with for your MapReduce jobs, where you're going to run your MapReduce jobs, and whether you're going to work with any other libraries and tools. So in this course, I'll be showing 2 different ways to work with the Hadoop binaries. I'm not going to just work with a sort of a raw installation. I'm not finding that that's a quick way to get up and going. You can install on Linux, or if you're part of the HD Insight beta from Microsoft, the internal beta is called Isotope, and you can run it locally on Windows. But that is the second thing, is it has to be approved. So I'm going to show the second and third options of the first section there, which is I'm going to work with Cloudera's demo virtual machine. I'm going to show spinning that up here in a couple minutes. You'll need virtualization software. I happen to run it on my Mac, and I use VMware. Works just fine. It's CDH4 or Hadoop on Linux on its virtual machine. You just download it and turn it on. You also can work with MapReduce on the cloud with AWS or with Microsoft if you're accepted into the beta. The challenge with the cloud is it is not free, and so you have to run really tiny jobs, and you're just sort of testing out your MapReduce logic, so it's really more practical to work with a local installation when you're doing any sort of development. For data storage, just as a point of information, when you're developing, you'll probably work from the local file system or in HDFS and pseudo-distributed mode, where you have a single node on your particular Linux box, and that's what I have on my Cloudera VM. When you work in the cloud, as you'll see when I do those demos, the expectation is that the source data and destination data will reside in that particular vendor's cloud, which can be problematic for some actual business implementations, but that's the way I'm going to show the demos. The MapReduce jobs themselves can be run locally on your local implementation or up on the cloud. And then you may choose to work with other vendor tools and libraries. I'll be showing some of the tools that come as part of the freemium offering for Cloudera. They have a browser, a GUI-based tool that assists in running jobs. I tend to stay away from the command line, although I will show it. We also have Hive, Pig, and some of the other libraries installed. So in the demo coming up, I'll show setting up Cloudera Hadoop VM and getting started with development. In this demonstration, I'm going to show you how to navigate the Cloudera website and select and find their distribution of Hadoop with MapReduce so that you can set it up using virtualization software on your particular local machine and get started developing with MapReduce. So here we are at the main site, cloudera.com, and of course they are one of many different vendors that create distributions. You could go directly to the open source distribution and get that as well, but for reasons that you'll see as we proceed through this course, I like Cloudera's developer distribution. So if we go here to downloads, you can see that we have their downloads. CDH4 is their most current distribution. Notice they have the different distributions here. So they talk about that it's based on the Apache distribution of Hadoop, and it includes some of the Cloudera utilities. Then they have Cloudera Manager, which is one of the tools that there is a free edition that they also sell. They have Cloudera Manager Enterprise Edition, and then they have a new thing called Impala, which I'll be talking about later in this course. If you scroll down, you can see that they have demo VM images here based on the Linux operating system. So in order to use those, you will have to have some kind of virtualization software. So if I scroll up and I go over here to Cloudera Quick Start VM, you'll notice that they have images that use either VMware, KVM, or VirtualBox. Now I've used the ones with VMware on a Mac operating system, with really no issues whatsoever. And here's a little bit of information about that. So I suggest that you do read their documentation. And once you've downloaded this, then I'll switch and show you what the VM looks like. So here's what the VM looks like. So this is running on VMware on my MacBook Air, and this is the standard sort of setup. So in addition to having the Linux operating system, Cloudera has installed Hadoop and some of their basic utilities. So if you take a look at the bottom here, you can verify that Hadoop is running by clicking on the terminal window, and I can just say Hadoop version, and then this tells me that I've got Hadoop 2.0 CDH4. Okay. In addition to that, you have navigation. You have the text editor, and you have navigation into the regular file system. Of course, we'll be also working with the Hadoop file system, HDFS, and then you have a web browser that has some pre-configured utilities on it. So if I open this up, you can see that we go to the Cloudera site, but we also have the Hadoop name node and the Hadoop job tracker and something called Hadoop yarn. And then we have Hue, this is a Cloudera utility, and HBase master. We will be looking in more depth at these throughout this course, but I just wanted to make you aware that these utilities are there, because I've seen several courses around MapReduce that do everything from the command line and or the text editor window, which is okay. And if you want to take that approach, that's certainly admirable. But I find that when you are learning new technologies, it's sometimes an easier path in if you use some of the graphical tools. To that end, I've also installed Eclipse on this VM. So Eclipse Juno, and I prefer to do my MapReduce coding in Java with Eclipse. There are many different editors out there, and the samples that I'm providing with this course can be their Java samples, so you can use your editor of choice. But this is the one that I'll be working with inside of this course, and this is not included as part of this Cloudera image, so you'll have to go out and download this from the source.